Okay, guys, welcome once again. So, in this edition, we are going to be looking at chain rule of differentiation. And in the last video, we discussed the power rule, and I proved the power rule formula. But I'm going to leave the proof for now. So, we're just going to look at the formula and look at a few examples. So, let's get started. So, when do you use chain rule of differentiation? Rather, chain rule is used whenever you have a function placed in another function. Let's say, given given a function given a function, let's say a function f of x to be equals to, let's say, g of h of x. I have this function. This function h of x is placed in a function of g of x. That means we have a function inside another function. Another name for this rule is called function of function. Function placed inside another function. So how do we find the derivative of this? How do we differentiate this guy here? So to differentiate this, f prime of x is given by df of x dx, and that is actually the same thing as. Now, the best way to use chain rule is this: differentiate what is inside that function. The function plays inside that function. Differentiate it first. So that means that's going to be h prime of x. Now differentiate the other quantity, the other function placed outside. So the other function placed outside is g of h of x. So you differentiate this guy here, this g. So that's, you multiply this by g prime of h of x. So I know this looks a bit confusing. So what am I saying? I'm just trying to tell you that if you have to use chain rule, the easiest way to do that is differentiate what is inside, keep it, differentiate everything as a single entity, like the external, the function you have outside, which is g. So that's going to be g prime of h of x. And this is like saying the h of x dx times the g of h of x dx. Okay, so don't worry. I'm going to illustrate this with an example. Let's look at an example. Look at this. We have, for example, if y equals 2x minus 4, or let's say 2x plus 3x squared minus 5 raised to the power of 2. Okay, so this is function placed in another function. This is a polynomial function placed in a function of square. So that means in this case, our h of x is actually 2x plus 3x squared minus 5. So that means our h prime of x, according to this formula here, is going to be the derivative of this. We know this, we're going to use power rule. Drop down the power, subtract 1 from the power. And that's going to, if you differentiate this is actually 2. If you differentiate this guy here, this is going to be 3 times 2x. And if you differentiate this guy here, if you differentiate a constant, is 0. You need to know that. If you differentiate a constant, is 0. A constant is a number that has no variable beside it. So anytime you differentiate an ordinary number, you always get 0. So this guy is going to give us 2 plus 6x. Okay, so this implies that our g of h of x, is actually the same thing as this guy squared. That's 2x plus 3x squared minus 5 all squared. So let's find g prime of h of x. So g prime of h of x simply means you should differentiate what is outside. That's the other function, the exterior one, and that's this square. So to differentiate this you're going to use power rule. So you don't differentiate what is inside here because you've done that already. So this is going to be 2 bracket 2x plus 3x squared minus 5. 2 minus 1, and that is 1. Let me just rub this off. So if you use power rule, drop down the power, subtract 1 from the power. So therefore, dy dx is going to be, according to that formula, that's y prime of x is going to be g, let's just say h prime of x dot g prime of h of x. And this guy gives us the h prime of x is 2 plus 6x times 2x plus 3x squared minus 5. You can simplify these guys, and this gives us, if you simplify this, maybe this 2 comes in, it goes there. That's 2 plus 6x, 4x plus 6x squared minus 10. So we can leave it this way, or whatever way you want to leave it. You can try to open this up, but this is just how to go about it. So the rest is just simple simplification. If you like, you can leave the answer this way, or you expand. Okay, let's take another example.